all this as the reference, we need to uh, find out the Z transforms. Okay, the Z transforms of the standard sequences are what we need to be knowing to solve these problems. Let's see the first problem here. See, in this, the signal x of n is given as 2 power n u of n plus 3 half power n u of n. Now, these are standard signals. Okay, so which standard signal this belongs to? Okay, you can take this as a reference to one of the standard signal. Which standard signal is that? That is a power n u of n. Which is a power n u of n? Which signal is a power n u of n? That is positive time exponential. So if you know the transform of the positive time exponential, we can directly write the transform for the transform for this. So what they mean by saying this is you're not again going by the equation. Which equation? X of z equal to summation n ranging from 0 to infinity. No, you're not going with that equation. You're going with the results of the standard sequences which we have obtained for a power n u of n, that is the positive time exponential. Similarly, this also is positive time exponential. But what is extra here? This 3 is extra here. Okay, so this 3 is scalar. We can just keep this apart. Okay, so in place of a, we have 1 by 2. Understand this point? So we have 1 by 2 to the power n u of n. So if we apply Laplace transform on this, how is that going to look like? Now see here. Sorry, it's not Laplace transform, Z transform. So if you are applying Z transform on this, how would this x of n look like? This x of n would look like x of z. Okay, that is what we see in the next step. So which are the transforms that we need to take for reference? This is the transform we need to take for reference. So we know what is Z transform of a power n u of n. So that is z by z minus n. And we also know that the ROC is outside the circle with radius a for this particular sequence. Now, similarly, if you take this particular sequence, what would be the Z transform of this? It would be z by z minus 2 ROC with z greater than 2. Okay, that is how we can do it. Now, before that, what we have to say is, then what is this? How would this look like if you apply Z transform on this? It would look like x of z. If you apply Z transform on this is how it is going to look like. Z transform on 2 power n u of n, Z transform on. Now 3 is there, right? 3 is taken outside. So you're applying just Z transform on the signal. From which property of Z transform it is possible? From linear property. Linear property very clearly says that you can take the scalar out and you can apply transform only on the signal. So by that linearity property of Z transforms, the 3 is taken out and Z transform is only applied on the function of n. Everybody is okay with that? Now, so because of this result, okay, so this can be written as Z by Z minus 2 and this can be written as Z by Z minus half. Okay, now once we have got the ROC, we should once we have got the Z transform, we need to also be aware of the ROC here. What is ROC telling? ROC very clearly says that it is for this transform, it is Z greater than magnitude A. Here it should be magnitude Z greater than 2 and here it should be magnitude Z greater than half. Now there are two ROCs. One says it is greater than 2, another one says it is greater than half. Now we should go to the properties of region of convergence to understand what actually is the region of convergence. There are two regions now. One says it is outside 2, okay. Another one says that it is outside half. So which one we need to consider? We should always consider the higher value. Understand that? We should always consider the higher value. So we don't say it is outside half, but we say it is outside 2. Okay, so this is what we obtained x of z. The first term has an ROC z greater than 2. The second term has an ROC z greater than half. Okay, since ROC is outside, z is equal to R max circle. So this is R max. What is R max here? The radius. These are the radius actually. We draw the radius with uh, 2, we draw the radius with half. So if you have 2 radius there, you need to consider the maximum radius circle. Okay, so which is the maximum radius circle? 2 is the maximum radius circle. Therefore, ROC is z greater than 2. This is the x of z, and this is the ROC. Yeah. Let's go on with the next problem. That is this. Let's move this window away from the I think there's some problem with there's some problem with sharing the screen. I'm just getting back. Yeah, now I think it's okay. Yeah, then the previous problem was this. Okay, we have found out x of z and ROC by looking at the standard transform. Now the next problem is this. Now which standard sequences you would remember by seeing this? Okay, there is a minus here. That minus can be attached to this 3 if you can take that inside. So you can adjust it like that. So here we used to have positive a, but there is a negative a here. Okay, there are two. This is positive time exponential, but that a is negative here. This is negative time exponential. Okay, with minus 3 power n u of minus n minus 1. This 2 is the scalar. Here this 3 is the scalar. Okay, so for confusing you, they adjust this in different ways. This is positive time exponential only because this is the u of n. U of n very clearly says that this particular minus half is ranging from 0 to infinity. That connection problem. Yeah. See here now. So if people are switching on their videos, please switch off your videos because every time the signal is going weak, the bandwidth is very low. So please see that you're not switching on your videos. Everybody switch off the video, okay? So fine. See here, it's minus half power n u of n. We have seen a power n u of n, but in this place instead of positive a, we have negative a. But this still is positive time exponential. So that is something one needs to understand here. So this is something that may confuse us. Okay, this may confuse us. See, this is u of n, this is minus. No, it's not that. Okay, and if we have minus outside, then it was something to be bothered about. But here the minus is within this within the bracket, and it is to the power n. Fine. Now see here, you have this signal. Now this is understood. This is a power n u of n. Now this is minus b to the power n u of minus n minus 1. So this minus can be taken with this. Okay, we make this plus 2 and this minus can be taken here. So what would this be? This would be negative time expression, minus b u of minus n minus 1. So you have both signal references. One is positive time exponential reference Here, this is the first signal, positive time exponential. Okay. The second signal is negative time exponential. Okay. So deal with the Z transform of this by looking at this. Deal with the Z transform of this by looking at this. The ROC also has to be clear. Understand that? Now, let's see how this can be done. See, in place of A, you have minus A. In place of A, you have minus A. Okay. Then what needs to be done? Okay. So the in place of A, you need to have to minus half. That's it. In this place, if I put minus half, how does this look like? Just a minute. Just a minute. I'm going off for. Yeah, come back. Sorry, I had some interruptions there. Now, so just compare this signal with this. So it's A, in place of A, you have minus half. Okay. And in place of this, you have minus 3. If it is minus 3, it is still 3. In place of B, it's as good as having 3. But in place of A, it's minus half. Understand that? So you have to take care about that. Now, yeah, if you take the Z transform of this, it is as good as applying Z transform of these signals. So when you're applying Z transform of these signals, 3 you will keep out, okay, and you will apply Z transform on this, okay. And here you will keep 2 out plus 2, okay, you will apply Z transform on minus 3 power n u of minus n minus 1, because this is what we need to have. So everybody able to understand that? No. Now, so see here, this is a power n u of n. In place of a, we have half, so it needs to be. Sorry, I don't know why today there are so many uh, hiccups there. Okay, I'm not able to understand, but still the signal seems to be okay, but still it's going off again and again. Yeah, fine. So this is what we have now. Now, what does the ROC says? If it is Z by Z minus A, ROC is outside Z greater than A. If it is Z by Z minus B for negative time exponential, yeah, again it went off, again it went off. Okay, so this is what we have now. We need to write the ROCs, but to see the ROC, we need to understand this. The ROC is outside Z greater than A. Outside is circle with A as the radius, and this is inside the circle with B as the radius. Okay, now we have to write the ROC. So this is the first term would have the ROC greater than half. So you may say this half is actually minus half. It should have been Z by Z minus of minus half. So this Z is this is supposed to be minus half. But see here, it says Z magnitude. So when it says Z magnitude, minus half is as good as plus half. Understand? This magnitude is taken, right? So it is plus half. If this magnitude is not there, then uh, it is minus half. But if this magnitude is there, it means that it is greater than half. Okay, or it says it Z is less than minus half is the meaning of this. Fine. So what would be the ROC for this? ROC for this particular term would be Z less than 3. This is negative time exponential. This is positive. Outside the circle with half as the radius, inside the circle with 3 as the radius. So it's a concentric. It's a ring. Okay, where the ROC is greater than half but less than 3. So you have a ring there in Z transform. Okay, now the next one is so ROC can be written as this is Z greater than half. Let's move on with the next problem. So here what they have done before going to the next problems here, they just taken the LCM of this. Okay, so take the LCM, that is Z plus half, Z minus half. So this would be Z minus 3 in the denominator, and this would be Z into Z plus half in the denominator. That's it. Okay, so they have just gone one step ahead to write these equations. Nothing much there. Now see this. Okay, if you see this, in place of A you have e power minus 2n. If you understand, this again is negative positive time exponential. Okay, this is negative time exponential, but along with positive time exponential and negative time exponential, we have another signal, that is impulse function, unit impulse. What is the Z transform of unit impulse function? Z transform of unit impulse function is 1. Okay, see here, if to obtain x of Z, you will be applying Z transform on all this. Okay, by linearity property of ZT, this 3 can be taken out. Okay, this 2 can be taken out, this 5 can be taken out. What does it say? So it is being applied on the whole. If you apply Z transform on whole of this, is what they are saying. Okay, so this is how we do the previous problem also. Okay, now here this is a power minus 2. This is written as 3 taken out, Z transform of a power minus 2 to the power n u of n. This is written as minus 2. Okay, this plus would be taken as minus 2, which is kept out, and another minus is taken inside this, so that it would look like the negative time exponential. There is a yeah. What is that? Yeah, I was talking about is there is a bracket missing here. Fine. So what would this look like? It's a power n u of n 1 by 1 Z by Z minus a. So it is Z by Z minus e power. This is what you need to be using for this. This is what you need to be using for this, the standard transform. And also this is what you should be using for this. Delta of n is equal to Z transform delta of n is equal to 1. So using all this, so what would be Z transform of this then? It is Z by Z minus e power minus 2. Here the Z transform of this is Z by Z minus 4. Okay, and the Z transform of this is 1. So keeping all that, we can write it like this. Okay, now the ROCs need to be taken care of. So how would the ROCs look like? The ROCs would, what would be the ROC of this? How to find out the ROC for this? Okay, the magnitude of this should be greater. Yeah. So what would be the ROC of this? ROC is Z greater than e power minus 2 means Z minus e power minus 2. The magnitude of this would be greater than 0. So from that, they have taken this. Similarly, Z would be less than minus 4, because see the ROC here. Z is greater than A, Z is less than B, we have taken, right? So on that basis, they have taken z is greater than a, that is e power minus 2, z is less than b, that is z less than 4, and this is all z for delta of n. Fine. Now, therefore, the ROC can be taken as it is not all z. This is eliminated. So the ROC would be greater than minus 2 and less than 4. This also is a ring in Z plane, okay, which is greater than minus 2 and less than 4. I think we will. How much time is remaining now? Okay, I don't know. The again and again the signal is. Yeah, let's stop the session for today. We have done some problems. Okay, I'll be posting these problems in Google Classroom. So today we shall stop. Okay, so before we stop, you give your attendance pass. We are 23 participants, and I want all the 23 participants to give your attendance in chat window. Make it fast. The signal is going off. Okay. Fine. I'll see what the problem is with the problem is with my mobile signal or what. I'll check over. Okay. It was not so happening earlier. Okay. Even from 2-3 days it's happening. Let me check that. Okay. So before and until then maybe we shall switch off now. Okay. So tomorrow we are making meeting again. Fine. Fine. I'll check over the problem till then. Fine. So don't waste time. Keep yourself prepared. Okay. So let's meet tomorrow. Fine. See you then. Bye bye.